Okay, number 44. This is a question that actually is, it looks confusing, but you need to just fall back on the math that you know. It tells you that a student transformed the data using a log scale on the vertical axis. Well, to be honest, I'm not sure what that means. I don't know that I've ever transformed data on a log scale on the vertical axis, but that's not the important part of it, because they tell you that the student determined that a good fit for C natural log of K was the regression line y equals 5.53 minus 0.11 C and y equals the natural log of K. Now, here's why this is important. There are no y's in your solution set, okay? So what it's basically saying is, if you know that y is equal to all of that and y is equal to all of that, then 5.53 minus 0.11 C, I've got a hiccup, sorry, is equal to the natural log of K. And that's the equation we're going to work with. So natural log of K is equal to 5.53 minus 0.11 C. And I keep looking back, and I'm noticing that there are no natural logs in my answer selections, which means I need to get rid of that. And the way to do that, because the inverse of natural log is E, I'm going to exponentiate, essentially bump this up into the exponent's place, the entire left side and right side. You can't do it selectively. It has to be the entire left side that you exponentiate and the entire right side, but that's okay. So I've got e to the natural log k is equal to e to the 5.53 minus 0.11 c. Now, because e and natural log are inverses of one another, they basically cancel one another, and that just leaves on the left-hand side k equals e to the 5.53 minus 0.11 c. Now, I'm much closer to the answers here, so I know I'm on the right track, but none of those answers look like this answer. So I'm going to remind you of something. If you had, let's say, x to the 5th, and you were dividing it by x to the 3rd, you can multiply it out. 5x's on top, 3x's on the bottom, cancel 3, and that would leave x to the 5 minus 3, which would be, of course, x squared. Okay, if you had a to the x squared over a to the b squared, let's just say, okay, that rule still applies. As long as you have the same base, you just subtract your exponents. And so that's the same as a to the x squared minus b squared. Okay, now those were just asides so that you understand where I'm coming from here, because I have a base to a subtracted exponent very similar to this, which means I can move it backwards and write e to the 5.3 minus 0.11 c. I can rewrite that as k is equal to e to the 5.53 over e to the negative, or sorry, it would be positive while it's down here, e to the 0.11 c. All right. Now, the reason that that's important is because the bottom still has, the numerator still, denominator still has a variable, but the numerator no longer has a variable. It's e to the 5.53. Well, because e is just a constant, and 5.53 is also a constant, you can just put that in your calculator. E to the 5.53 is equal to about 252, okay? So that right there, I can actually write as k is equal to 252 over e to the 0.11 c. Okay, I'm real close, I think. The only difference is here, and that doesn't look right. Let me just read. That's the 0.11 c. Whenever you have a value in the denominator, if you want to move it to the numerator, you can actually rewrite it as 252 times e to the negative 0.11 c, because you've moved it from basically a negative in the exponent's place just means that it has translated to, if it was originally in the denominator, as in this case, it's in the numerator, and vice versa. So k is equal to 252 e to the negative 0.11c. That answer is